Okay, so we're dealing with matrices and transformations. Oh, before I go too far, let me mention to you an opportunity for extra credit if you want to take advantage of it this chapter. It's going to be due Monday, so if you want to do it, this is due on Monday. So pay attention. If you want to do the extra credit, you can do page 180, the Dominion modeling. It's not a whole lot to this one, so you'll have to do all 9 questions, and you'll need to include the original questions with your answers. Hey, if you want to do it in Word, great. In other words, if you want to type it out, perfect. Or you don't have to, you can write it out. But it's page 180. I think it flows over to page 181. It's the Dominion modeling, questions 1 through 9, and include the original with that. Or if you want to go a different route, there's a programming project on page 168. You can make a program that will solve matrices using Cramer's rule. If you enjoy programming and you want to go that route, feel free to go that route. In either case, those would be due on Monday. Okay? All right. We're looking at matrices and transformations. Remember, we said there are 4 ways to manipulate or change the shape of a figure. The original is called the pre-image. The change shape is called the image. We talked about translation on Tuesday. To translate, how do you do it? It's simply matrix addition. Matrix addition. The example there at the bottom, we added 5 to every x coordinate, so we moved it 5 to the right. We added a -4 to every y coordinate, so we moved it down 4. That was the bonus, basically, on the quiz. And again, a matrix equation has an equal. Some of you left the equals off, but equations have an equal sign left-sided and right-sided. So that was the first one. Then we talked about reflection. You can be reflected about the x-axis. You can be reflected about the y-axis. You can be reflected about a 45-degree angle, which is x equals y or y equals x. And the way you do it is by matrix multiplication and specifically left multiplication. Correct? I was going to say right. Right? You got to go left multiplication, and it matters what you multiply by to make it do that. So we went through, and if you're going to reflect it about the y-axis, that's the matrix you'll multiply by. If you're going to reflect it about the x-axis, that's the matrix you'll multiply by. If you're going to reflect it about a 45-degree angle, then that's the matrix you'll left multiply by. And if you want to do it against a negative 45-degree angle, then that would be the matrix you multiply it by. All right, and I think we left off then the last thing. So let's finish this off. So we decided to reflect this about the y-axis. So let's finish this thing off. Got to do matrix multiplication across and down. I'm going to do most of it in my head. So across the first row and down. So -1 times 1 is a -1 plus 0, and the first element, right, is a -1. Across and down now, the second column. -1 times 3 is a -3, 0 times 4 is 0, so you get a -3. Across and down the last column, -1 times 4 is a -4, and 0 times 2 is 0, so you get a -4. Across and down, so I'm going across now the bottom row, down the first column. 0 times 1 is 0, 1 times 2 is 2, so bottom is a 2. 0 times 3 is 0, 1 times 4 is 4, and 0 times 4 is 0, 1 times 2 is 2. And if all is right with the world, those are the coordinates of our translated figure. So the image ends up at -1, 2, right there, and that should be n prime, -3, 4, and that should be O prime, and -4, 2, and that should be P prime. And hopefully that looks like a mirror image about the y-axis. So matrix multiplication. And again, it matters what matrix you use to multiply. Why do we say left multiplication? Because matrix multiplication is not commutative, and you couldn't even multiply them if it was the other way around. All right, any questions on that? Anybody? Questions? 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 Okay, so translation, we moved it. Reflection, we did a reflection of it. Next one is rotation. Rotation. You want to rotate the figure. So you got figure ABCD, right? Quadrilateral. Specifically a geometry. What kind of shape is that shape? Trapezoid, right? A quadrilateral with one pair of parallel sides is a trapezoid. So it's a trapezoid, and we're going to reflect that. What in the world did I do with this one and that one? They're like stubby. I don't know what I did. Oh, well. First editions, such is life. I just looked at them like they're stubbed out there. Something's off on that. Either that or like the scale came out funny. Yeah, it's just the scale. All right. Do they look funny on your sheet? See, they look normal on the screen. So it's my screen. Must be scrunching it. Does it look normal on your sheet? Okay. It's just a perspective on the screen. All right, no big deal. Okay, let's go through and do the pre-image. So again, we're going to look at the coordinates, right? I think one person on the quiz didn't go in order. Go in order. If you got an A, B, C, D, just go in order. So the x-coordinate of A is a 2. Right? The B coordinate or the x coordinate of B is a, come on, participate. And the x coordinate of C is a, and D is a, all right, let's go on the bottom row. We'll do the y's. So y of A is a 1, and y of B is a 3, and 3 and 1. Okay, so let's take a look at the 90-degree rotation. So if we go across the x's, so A prime is a -1. The x of A prime. The x of B prime is a -3. The x of C prime is a -3. And the x of D prime is a -1. So if you look at the original, all the y's are now on the top, and they're the opposite sign. And let's see, the y's now end up being, what, 2, 3, and it's probably 5, 5, right? 2, 3, 5, 5. And look at that. All the x's are now on the bottom as the y's. So the y's went up top and are all the opposite sign, and the x's went on the bottom. And that gave it a 90-degree rotation. Every rotation is going to be different. Remember how a minute ago when we reflected, it's different if you reflect about the x-axis, y-axis, positive 45, -45. So is the same here. You're going to have a different matrix. So the operation of rotation also involves left multiplication. So if I ask you guys to rotate an object, I will give you the rotation matrix. You have to know to left multiply it. You have to know how to do matrix multiplication to end up with the resulting matrix. But I'll give you each one. Okay, so that's the one we just did. A 0, -1 top row, 1, 0 bottom row causes the bottom to become the top with negatives and the top to become the bottom. Okay, that's the matrix multiplication for 90, 180, -1, 0, 0, -1, and that's going to now rotate it. So again, when you're working on a computer program, I use CorelDRAW as my drawing program. Anybody use Illustrator? Microsoft Illustrator? Does anybody use any kind of drawing type program? Luke, do you use one? Illustrator? That's Adobe, right? Is Illustrator? I think it's probably the standard. Do you guys ever use a drawing program? Like Word is a word processing program mostly to electronically draw. I'm not talking about, okay, like draw a picture. I'm talking about the capability of I use Corel Draw 13, which is kind of a little old. It's one that I know, so it's just one that I use. So if let's grab a shape here. It is not doing anything but what I want. All right, let's get rid of that because it won't illustrate my point. Drawing program. Okay. Ooh. All right, so if I go up here and I want to transform it, look at that. Transformations. Amazing. Now, they don't say dilation and all that, but here, let's rotate it, right? Because that's what we're doing right now, rotations. And fly down, and let's rotate it. Let's go 180. And la-di-da. So how in the world did it do that? Magic, right? Obviously the programmers have arrays. Arrays are matrices. My guess is it may be even beyond that, but it is one way that you can do it, is to have an array and multiply it times the proper matrix. All right, so 90, again, counterclockwise is a 90-degree rotation. Counterclockwise 180, multiply by that one. What if you want to go 270, then 0, 1, top row, negative 1, 0, bottom row. And it's kind of boring to rotate 360. Right. Hopefully you caught that. Some didn't. All right, rotate it 360, you're right back where you started. Okay, so I'm going to pause. I want you guys to write the matrix equation that's going to rotate this, and we're going to go, why did I do 90 again? That one up there is 90. Let's go 180. 180 and graph the image. Remember, left multiplication, okay? Go ahead, see what you can do. By the way, the pre-image is going to go in here, right? Okay. And then you're going to do multiplication, matrix multiplication. And when you do, hopefully you end up there, right? And you rotated the pre-image 180 degrees. And again, the matrix multiplication is easy because the other number across any row is the 0, which makes life easy. Remember, across and down. Across the top row, down. So just negative 1 times 1. Across the top row and down the middle column, just negative 1 times 3. Across the top row and down the last column, just negative 1 times 4. Then doing the bottom row, across the bottom row, it's just the negative 1 times the bottom number, negative 1 times the bottom number, negative 1 times the bottom number. That's it. So really, how do you rotate 180? In a flash. Change the sign of every coordinate on the top, change the sign of every coordinate on the bottom. Don't say change every top to negative, because what if something was negative already in the pre-image, right? Change the sign of everything on the top, change the sign of everything on the bottom. Boom, rotate it 180. Which, by the way, can anybody think up of a quicker way than matrix multiplication to rotate an image 180 degrees? Hunter? By scalar multiplication by negative 1 will also rotate it 180 degrees. Because we're just changing the sign of every single coordinate. Okay. Dilation. Right, that was the fourth transformation that you guys remember from geometry. Because you did all these and you have good memory. And you studied when you had geometry, so you remember. So dilation, easiest way to remember is your eyes dilate with light and such. So dilation. Transformation, where the object is reduced or enlarged. Now, in everything else, when you transform something, are the pre-image and image congruent? Yes or no? Let me give you a visual. Okay, so there we did transformation. Are those objects congruent? Yes or no? Congruent. All corresponding angles are congruent. All corresponding sides are congruent. Yes, right? Okay. Then we went to rotation. Are all corresponding angles congruent? All corresponding sides congruent? Yes. Then we went to, did I skip reflection? I skipped reflection. All corresponding angles are congruent. All corresponding sides are congruent. As with rotation, how about dilation? Are all the corresponding angles are congruent? Are all the corresponding sides congruent? No, but all the corresponding sides are, what's the next word? Proportional. And that would be the definition of, y'all had it last year. What kind of figures? Similar figures have congruent angles and proportional sides. So producing a similar figure. Okay, so we got a pre-image there, the little blue image, and then you've got the corresponding enlarged image. So again, let's go through, and for time's sake, I'll just belt out these coordinates. If you go A, B, C, D, it's 2, 3, 5, 5. Across the top row, 2, 3, 5, 5. Y coordinates of the pre-image, 1, 3, 3, 1. Again, 1, 3, 3, 1. Okay, so if you look at the enlarged image, by the way, the enlarged image is also translated, isn't it? So there's movement here as well. So you just got to understand part of that. If I put it right over top of it, then it'd be hard to see. I guess I could have. But anyhow, the coordinates are 4, 6, 10, 10. 4, 6, 10, 10. And the bottom row, 2, 6, 6, 2. 2, 6, 6, 2. All right, so dilation, you can either enlarge or you can reduce. You know, if I real quick jump back to my drawing program, you know, when I pull a corner, and you guys do that, right? You know how to do that, pull a corner. I mean, you do that on photos, right? What is it doing? Producing a similar figure, right? So now I'm enlarging it. And like, this is what I do to my photos. Do I have a similar figure right now? You see what I just did? Why do I do that to my photos? Because I just got thinner. That's why. Do this to your photos and you will get fatter, all right? Right? Squeeze it in sideways and you'll get thinner. Push it in top to bottom, you'll get fatter. All right. Or I could pull from the top, right? I mean, I could squeeze in the sides or I can pull from the top. But that's not a dilation. That is a distortion, right? I like it when my pictures are distorted. That's much better in my mind. All right. The scale factor. Scale factor. K is the designation for the scale factor, and it determines the dilation. So if K is less than 1, it's obviously a, if you can see the color, you're going to think a reduction. So if the scale factor is less than 1, you're reducing that thing. And if the scale factor is greater than 1, it's going to be an enlargement. So off to the right there, I've got the question, what is the value of K for the above dilation? What is the value of K? Show me in fingers if you know it. See a couple of them out there, and they're in the back, so everybody else can't see them. People in the back are catching on. They can see. All right. And the K factor on this thing here, I'm going to use blue, right, is 2. Does anybody see how a 2 does anything from there to there? Abigail? So what kind of multiplication would that be? So scalar multiplication, right? If we scalar multiply the first matrix by 2, we get the second matrix. We just doubled the size. We enlarged it by a factor of 2. All right, so to transform an object by dilation, use scalar multiplication. And you're going to multiply by the value of k, right? So k times the shapes matrix, if you know k. She's nice. Billy, not so much, but K's awesome. Okay. So, last thought of the day. Remember now, you guys got to deal with translation, move in location. You got to deal with reflection, reflect about the x, reflect about the y, reflect about a 45, y equals x, or reflect about a negative 45, negative x equals y, or y equals negative x. And then you have to worry about dilation, you have to worry about rotation, rotate it 90, rotate it 180, rotate it 270, and then lastly, dilation, enlarge it or reduce it. All right, so take the shape there. Its matrix is going to go right there. Go ahead and reduce it, right? Because k here, in case you didn't catch on, k equals 1/2, right? And go ahead and reduce it and draw the resulting image. All right, hopefully you ended up doing that, right? Dilation, I don't need to give you a matrix, right? If I say, hey, dilate an object by a k factor of 7, scalar multiplication by 7. Reduce an object by k equals 0.4. Ooh, decimals, we're going to shake in our boots. Who cares, right? Just multiply by 0.4. It's a fraction, just multiply by the fraction. And anything below 1, you're going to reduce it. Anything greater than 1, you're going to enlarge it. And if you multiply by 0, it will disappear. Any questions? Anybody? Anybody? All right, you got about 10 minutes left in class, and I can help you with homework if you got any questions.